Today you might see k divided by x plus 1 or something, so it's not exactly an inverse, but it is similar, and it's called a reciprocal function. So a reciprocal function is any function that belongs to the family whose parent function is f of x equals 1 divided by x. So we've done graphing with quadratics, they were parabolas. We did polynomials. We did square roots, which were the shooting star. We did cube roots, which were the sideways like s. So now we're going to be graphing reciprocal functions. The parent function, remember, is before it's been shifted or stretched. It's the basic form of the graph. We're going to graph this below. Notice it does say that x cannot equal 0. What would happen if x did equal 0? What is 1 divided by 0? What? 1. Nope. It's not a number.
Error.
Error, what's error stand for? It starts with a U. Undefined. Okay, so when we graph these, we are going to have what are called asymptotes, vertical asymptotes and horizontal asymptotes. We introduced this word before when we had our square root graphs. The asymptote is an imaginary line that the graph never actually touches, but it gets really close to that. Okay. A reciprocal function can be written in this format. So it's similar to what it started out with, but we have some different letters that are representing translations, shifts, left, right, up, down. It also tells us things about the asymptotes and what the equations will be. Now when we look at these, the graphs of these will typically look like, I'll just do a little sketch here. They'll look like this, typically. So they are called branches because the function itself is not considered to be continuous because it kind of skips from one part to the other. These are called branches of the graph. I don't know if you have any pictures on your paper, so you might want to draw those. When we're graphing these, we will typically have a vertical and a horizontal asymptote. The vertical asymptote will be, in this case, at the line x equals 0. The horizontal asymptote will be at the line y equals 0. If you have different colored pencils or highlighters or something, you can use those to draw them in, because sometimes it's hard to see in pencil on like a grid that you have like a dashed line there. But again, these are your asymptotes where the curve's going to get really close to it, but it's never going to touch it, it's never going to go across, it's just going to get really, really, really close, infinitely close, as it moves out. So the domain and range of these things are going to be all real numbers except our asymptotes, the values that they can't be. Now, in terms of the a, the x, the h, and the k, let's talk about what those stand for. So the a value is normally our stretch. In this case, we are going to say that the absolute value of a, remember the absolute value makes it positive. If a is greater than 1, it is considered a stretch. A shrink will be if the absolute value of a is between 0 and 1. So that would be if it's a fraction, like 1/2, 1/3. Could be negative, but again, when you take the absolute value, it'll become positive. And then if a is less than 0, meaning it's negative, then that's considered a reflection. Now in this case, it'll be a reflection across the x-axis. Kind of just like we did the parabola, we would flip it downward. It'll be the same thing, but the graph, the one branch will flip down, the other branch will flip up. So they go to like opposite quadrants. So you can see an example here is our a value again. This is going to indicate a stretch or a shrink. Or a reflection if it's negative. And then we also have our translations, left and right. So the horizontal translation is the variable h, and I just have x equals h. This is the one that's going to move left or right, and it's the opposite direction that you think. Just like we did before, it was normally in parentheses whenever we did for a text form. And then the vertical will be the plus k. and that will be up or down. And then this is, of course, our combined variation over here. Now, we talked about the asymptotes above, which are the imaginary lines that it never touches. So I don't think this is in your notes exactly, so let's jot it down. I guess here we have some space. So for vertical asymptote, so we don't have to write that out, and most of you will just completely butcher the spelling of asymptote, right? Probably. We'll abbreviate that just VA for a vertical asymptote. The vertical asymptote will always be x equals, because it has to be vertical, going up and down, and it will be x equals h. So it'll be whatever is being subtracted in the denominator. And so if it were x minus 2, the vertical asymptote will be x equals 2. It's actually the restriction, the number that it can't equal. Remember, the denominator can't equal 0. A horizontal asymptote again, spelling, writing out too long, so we'll abbreviate that HA. The horizontal asymptote's equation will always be y equals k. And that'll be whatever the k value is at the end. So if you want to put this into your notes, we can say that the h value will be the vertical asymptote, the k value will be the horizontal asymptote. And our main goal today is going to be to graph these. We will use our calculators. I'll let you use your calculator on the quiz, but I'm going to show you how you can also do it without, in case the SAT would need you to. But you will have your calculator to assist you. You'll still be asked a lot of questions like, what is the vertical asymptote? What is the horizontal asymptote? What's the domain? What's the range? So you still need to be able to answer all of those, but you can use your calculator to help you. So example 1 is just the parent function before it's been shifted or stretched or anything like that. And they want us to state the domain and range, vertical asymptote, horizontal asymptote, so on and so forth. So normally the equation is, well, it could be a or 1 divided by x minus h plus k. Okay, now in this case, we have nothing being subtracted and the denominator being added. So this is really x plus 0 plus 0. So if you want to put those zeros there to help you realize that the h value is 0 and the k value is 0, you can. So remember, the vertical asymptote will be x equals h. The h value is 0, so this will be x equals 0. So if you go to the y-axis, which is where x equals 0, you can draw a dashed line to show that vertical asymptote. Again, imaginary. When you're graphing calculator, it's not going to show up, I don't think. But you'll notice that the curve's getting really close to that. The horizontal asymptote is y equals k. The k variable is at the end, so this one will be y equals 0, which is horizontal at y is 0. So go ahead and sketch that in. A lot of times they will be the x and y axis, but when we start shifting up, down, left, and right, the asymptotes can move. All right. Now, I like to graph first. Most of you are visual people for domain and range. Usually, you like to see the graph before you identify domain and range. So if you were doing this without a calculator, you would do a table of values. Remember, when in doubt, table of values. There's not a lot of numbers that are going to come out to work. So I actually tell students it's easier if you rearrange this equation. So if you multiply by x on both sides, you'll get x times y equals 1. And then you guys can logically think what two numbers multiplied together can get me 1. So 1 and 1, right? And what else? What times what will get us positive 1? 2 times 1/2. What else? Sven? -1, -1. This would be without a calculator. Okay. If we have our calculator, we just type in our y equals. We get our table. We also could have -2 and what? -1/2. And that's like pretty much it. I mean, you can come up with more of them if you want, but you really just need a couple points. And again, most of them are just going to have that branch look to them. So let's go ahead and plot those points. So -2, -1/2, -1, -1, +1, +1, +2.5. And then you again need to know that you're not connecting all 4 dots together. They're going to have 2 branches to them. And you just have to estimate almost all of the rational functions and reciprocal functions are going to look like this. So there's not a lot of points that you actually can plot. So the domain for this, it does go left forever. So if you were doing this using interval notation, it would be -∞ to 0, but it doesn't ever touch 0. So it would be -∞ to 0 parenthesis, not a bracket. And we'd have to use the union symbol, if you remember that, to skip over 0. And we would go then from 0 to infinity. Now that's the long way to write the domain. You can write it like that if you want. But personally, I like to write less. So another way that you can write that is all real numbers, except, what number is it not allowed to be? Where's the asymptote? 0. So you can write all real numbers except x cannot equal 0. Make sure you have the cannot equal 0, not equal 0. So either one, I don't care which way you write it, but when you get to pre-calc and calc, you'll see it both ways, so you'd be comfortable with identifying both. But Mrs. Cotton, I asked her, and she said if given the option, she'll write the second one, the shorter version. All right, the range, same thing. Goes down forever, comes up to 0, doesn't touch 0, skips over 0, goes to infinity. So you can either write the same thing for this, or if you want the short version, all real numbers except, now in this case, it'll be y cannot equal 0. And let's all type this in our graphing calculator just to see what it looks like on the screen. Those of you with the newer calculators, you will get a better picture. So 1 divided by x, zoom 6, of course. And does that look like what we had on our paper? Close enough. Now again, your calculator looks like it stops right there. It does keep going. It just gets really, really close to 0, so it doesn't show it. You do need arrow tips at the end. Again, when you're doing this, you can go second graph and it gets you your table, which I'm all the way up in the 40s, but if you go back down to the smaller numbers, you will see the values that we picked. You also will see an error where there's an asymptote, okay, because that would be your divide by 0 error. But you can see this has the same numbers that we picked and did by ourselves. Okay. So with a graphing calculator, these shouldn't be hard problems because you can use it to assist you. All right, let's flip to the back. They want us to, in example 2, graph the function and identify the x-intercept, y-intercept, and the asymptotes of the graph, state the domain and range. So this difference between the last one and this one is we have an a value of 4. Okay, so this is a stretch. Okay, so it's actually going to pull it away from the origin a little bit, stretching it further. All right, so let's graph it first. And with a graphing calculator, you can just type this in your y equals, press graph. Let's try to do it mentally. Again, the easiest way to come up with your table of values is actually to move the x over to make it x times y equals 4. If you're doing this without a calculator, this is the easiest way. And then think about what 2 numbers can multiply to get me 4. Well, 1 and 4, 4 and 1, right? What else? 2 and 2. And we can put negatives on them, right? So like -4, -1, and -1, -4. You can get more creative too, like half and 8, whatever. But you don't have to have that many points. You'll usually have a pretty good idea of what's going on. All right, we also want to identify what our asymptotes are probably first. So let's write our vertical asymptote and our horizontal asymptote. Again, the vertical asymptote is x equals h. But there's no h in the denominator. This is really 4 divided by x plus 0 plus 0. So the same thing as last time. It hasn't been shifted left, right, up, or down. So the vertical asymptote is x equals 0. And the horizontal asymptote is y equals k. So that's also y equals 0. Eventually these will change. So let's put those. Make sure they're dashed lines. And that way you know those are the lines it's never going to touch. It's going to get close to, but not touch. And we can plot our points. So -4, -1, -1, -1, -1, 2, 4. 1, 4, 4, 1. Okay, so not a lot of points, right? You're just going to do a nice estimate. We know it's going to go this way and this way, looking like our branches. Oh, I forgot -2, -2. I guess I could have plotted that one, but it ended up in my sketch anyways. So the other thing they asked us were the x and the y intersect. So where does the graph hit the x-axis? It doesn't. Where does it hit the y-axis? Doesn't. That won't always be the case, but in this problem it was, because that's where our asymptotes were. State the domain and range of the function. Do we like the short version? All round numbers except? Okay. All round numbers except what? X cannot equal 0 again. And range will be the same thing, but include y instead of x. Make sure you have the do not or cannot equal sign. So you're going to notice that the vertical asymptote is going to have an equal sign, because it's an equation. The domain will have the same number with a not equal to. Those are going to always match up because they are restrictions. All right. Make sure we get to the example 5. Which one do you prefer here, 3 or 4? We won't do both of them. 4. Okay. So 4 has y equals 1 divided by 2x. So you want to remember that you can rewrite this as y equals 1/2 times 1 over x. Or you could also think of it as 1/2 divided by x, right? Because the 2 would move into the denominator. So the a value is less than 1, so this would be a shrink. I think this one actually says describe the effect of a on the graph. So since a is 1/2, it's going to shrink the graph. And when it shrinks it, it will get closer to the origin. Now, they don't ask you to identify the vertical and horizontal asymptotes, but you kind of need to know what they are to be able to graph them. So, remember, this would be plus h, or minus h, which is really 0, plus k, which is also 0. So we still have them at 0 and 0. So the vertical asymptote is still x equals 0, horizontal is y equals 0, the same as the last 2 examples. In the next example, I promise it will be different. But a lot of your homework, they will be on the axes. Let's use our graphing calculator for this one. Obviously, you could do it by hand, make it x times y equals 1/2, and think about what multiplies to get us 1/2. But let's do one on the calculator. So go to our y equals button, type in 1 divided by. Now because you have two things in the denominator, you need parentheses, 2x. And zoom 6. Again, it looks like it stops, but it does keep going. If you want to get some points that are plottable so that you can better than sketch it, go to your table, second graph, and you can clearly see there's an error at 0. But you can get a couple points that you could plot, like 1, -1/2. And 1, +1/2. All the other numbers are pretty small. I mean, you can plot them, but it's going to be an estimate when you have like 0.25 and so on. I'm going to use a different color so it stands out. Then they're all going to look pretty much the same. They're going to have the two branches. Now the one that we didn't do here, it would have been a reflection, so they would be in the different quadrants because of the negative. But as long as you have your horizontal and vertical asymptotes, and this sketch is pretty good, you're fine. It doesn't have to be exact or perfect. Now we do have one more, and this one is actually going to be shifted left, right, up, or down. So this is called a transformation or a translation. So in this case, remember the original formula is ax minus h plus k. A is the stretch, h is shifting left or right, k is shifting up or down. And they also tell us about the vertical and horizontal asymptotes. So let's find those first because I like to do those before I graph. What is the equation for the vertical asymptote? X equals, h, and the h value was 2. So x equals 2. And then our horizontal asymptote, and if you want to put that, is y equals k. The k value is 3. So when we go and plot those, x equals 2 is vertical at 2. Finally, one that looks different. And y equals 3. So the branches are going to go close to those instead of being close to the x and y axis. All right, again, let's use our calculator this time to do our table of values. So go to your graphing calculator, go to your y equals. You need parentheses, so it'll be 1 divided by parenthesis x minus 2. Close your parentheses, and then plus 3. If you want to put an extra set of parentheses around the 1 divided by, you can, but your calculator will know to divide before it adds. Zoom 6. Again, you're not going to see the dashed lines that we drew in, but they're imaginarily there. Is anyone not seeing that? You have something. Your asymptote is showing up. So some of the older calculators, your asymptote will show up. It looks like only the vertical one showing up, not the horizontal. So that shouldn't be in your graph, or that should be the dashed part. All right, now to get that on our paper, we probably want to get our table to be able to plot some points. And you don't have to write this down. You can just plot them from your calculator screen, but just for notes so we know what we're plotting. So maybe like 0, 2.5, 1, 2. I like to pick like whole numbers or half numbers. Notice that 2, there's an error, which makes sense, right? There's an asymptote there. 3, 4, and 4, 3.5. Not a lot of points, but we know it's going to have that branch shape to it. And you can use your calculator screen to get an idea of what it does look like. It also asks us to state any intercepts. So, the y-intercept, remember, occurs when x equals 0. So that one we actually found in the table. When x is 0, y is 2.5. That one was easy to find in the table. How do you find the x-intercept? We can see that it's like approximately here, but how do you find it, like algebraically? For the y-intercept, we plug 0 in for x. So for the x-intercept, we would plug 0 in for y. So for this one, you probably want to do a little bit of algebra off to the side, maybe up here. So it would be 0 equals 1 divided by x minus 2 plus 3. You then need to solve for x. So we would subtract 3 on both sides. We would undo division of x minus 2 with multiplication of x minus 2. And you need to distribute. So that'll be negative 3x plus 6. And then solve for x. Subtract 6 and divide by 3. So negative 3x equals negative 5. Divide by negative 3. X will equal 5/3. Which makes sense because that's 1 2/3, which looks like about where I plotted it. X-intercept's always harder than the y-intercept. And then domain and range are the last thing. Domain is all real numbers except what? X cannot equal 2. Good. Range is all real numbers except 3. All right, try the closure with your partner. You can use your graphing calculator. Negative x plus 3 equals 2. So we should get x equals 1. So the x-intercept should have been 1, 0. And you have to do a little bit of algebra for that one. That's the only one you really have to do work for. And then you can plot those points. The x-intercept is 1, 0. The y-intercept is at 0, 1/3. That should get you a good enough picture here, and then you know the other ones up there. You can use your table of values. Domain, all real numbers except 3. Range, all real numbers except 1. Get on your